Okay, so like you said, median is the middle. So our technical definition is the segment that connects the middle with the vertex. So it connects the vertex of the triangle to the midpoint of the opposite side. I need a pen that looks like you got it. So if we were to draw this here, and I'm just going to draw an example, I'm not going to measure, but I'm estimating that the middle of the bottom is probably about right here. In your project you will be determining that exactly. But the median is going to look something like this. So the vertex to wherever the midpoint of the opposite side is, no matter what the shape of the triangle is. Do you guys know altitude? You told me it's the height of something. How do we determine that it's the height and not like a slanted line? Yeah, it has to be straight up and down, right? And so our definition is just, it's the segment that goes through the vertex and is perpendicular, so we're at right angles. If I do my perpendicular symbol, you guys should all remember what that means. If not, write the word perpendicular on your notes. And so altitudes, even if you have a triangle like this, it's often not going to the center of that other side. It's just wherever you can get that perpendicular line. All right, any ideas what perpendicular bisector might mean? Okay, what does perpendicular mean? Yeah, so it's going to form a 90-degree angle. What's a bisector? Halfway. And so perpendicular bisector, we're going to come to the half, so to our midpoint, and then draw a perpendicular line there. So it's not cutting the triangle in half because it's obviously uneven, but it's bisecting it at that midpoint. Okay. And do you think each of these could be drawn from every single vertex and every side of the triangle? In theory? Yeah. So I mean, I could draw, like here I did it this way. If I turn my paper this way, I could draw another median from there to the midpoint of here. I could draw another altitude perpendicular. And so it can be drawn from any side of the triangle. When you get to your project, though, it is very important to make sure you use the points that I assign you, because if you try to make your own points, you may not be able to do every step of the project. So some triangles you can't do every step on if it's, well, there's a reason we're giving you 2.5 class days to do the project. There's a lot of steps, there's a lot of stuff y'all are doing in it. Okay, you ready for the next part? Are we still writing? Okay, so these are the things, and the reason we're doing a project instead of a test over this is project means everything is open note. You guys can ask for explanations. I can't help you on the project because it's a test grade, but you can ask for explanations, you can check each other's work, and so these are the 4 things that we're using here. And so circumcenter is created by the perpendicular bisectors. And these are tiny little blanks here, but what we fill in is just the circumcenter is equidistant. Do you guys know what equidistant means? Equidistant? Equal distance from each vertex of the triangle. And on the next page we'll go over how to find that. But if you just look at the drawing, you can see that 3 perpendicular bisectors were drawn, and the point that they meet is called the circumcenter. Incenter is just formed by angle bisectors. This actually is not one we're using on the project, but and so this one is equidistance from each side of the triangle. Centroid is created by medians. And so centroid is created by a segment. Connected to a midpoint of the opposite side. So basically it's just when we draw the 3 medians, where do they cross? And then last one, the orthocenter is created by the altitudes. So just drawing those altitudes and seeing where they cross. Okay, so when you have all that, flip over to the next page. Can I change mine yet? Okay, so this page, we're going to do a couple together, and then you're going to finish up in your groups and then we'll go over the next page too. So this one, we're just identifying everything as a median, altitude, angle bisector, or perpendicular bisector. So it's just a vocab sheet. What do you think this first one is? Yeah, so angle bisector. What do you think the second one is? So it is perpendicular. So is it the bisector or is it the altitude? Yeah, because it's going to the vertex, we know, and it's perpendicular, we know it's the altitude. Okay, so I'm going to pause the recording and work with your group to see if you can finish this page. All right, so what did y'all get for number 3? Median, yep. And how about number 4? Altitude. And how about number 5? How about number 6? Was there a question on that? Because we know it's marked perpendicular. And you guys see how, like, number 3 looks the same as number 6, just the perpendicular isn't marked for us, and so then we just label it with what's marked, which here we know it's the median. Alright, how about 7? 7 was a little tricky, wasn't it? And you guys see it it kind of shows the dotted line here. Sometimes with altitude you have to draw outside of it. It's an obtuse triangle. That's why you have to do the project with the points I give you, because if you made up your own points and had obtuse triangles, a lot of things just won't work well. All right, what'd you get for number 8? Mm-hmm. And altitude. So when you have that, flip to the next page. Okay, so this is almost the same, except here it's going to ask us to sketch it, which means altitude. What do I have to do for altitude? Find the middle or find the perpendicular?
Middle. Perpendicular.
Yeah, altitude. And so we're not measuring here, we're sketching it, so it is an estimation. The altitude should be straight up and down from whatever point that is. And then we do it perpendicular. Alright, next one says median to B. So if I need my point to come hit B, what side is my median going to be on? So I just find the approximate middle of that, because we're just sketching, and draw my median. Okay, so we're going to take a couple minutes, finish that up with your group. So when it said perpendicular to a line, that just means you find the line. Go. All right, one packer. So angle bisector, as I was coming around, no one seemed to have trouble with that. Median to AB, so when it switches, instead of like median of C, we're just finding AB and go up to the opposite vertex. Altitude to B, I saw a lot of variations here. So some people gave me the altitude of A. Some people, I think some people came up here. Only the problem with that though is it has to be perpendicular. So if you were trying to come up here, it would have to be like way up here before you could get a perpendicular line to AC. So it's usually easiest to come out like that.
Hey. Is there proofs in this topic?
Not like formal proofs. You have to like show your work and show how you got your numbers, but it's more numerical.
No, I mean like proofs from...
Yeah, and then there's not like proofs in this topic. Yeah, you guys have gotten the majority of proofs out of the way for the whole year. There's not a whole lot in the spring. Okay, you guys ready for the next page or not yet?
There's another page.
Okay, the next page is where we get the numbers and how to actually find these.
Okay, now it's good.
Now you ready? Okay, so this is the part, that was just the vocab part. This is pretty much what you're going to be doing on your project. So we're going to work through this whole page together, and that's virtually all you're doing on your project for the rest of the week. And so let's start. This graph did not print real well, but I'm going to start by labeling points. So what is point G?
-5, -5.
All right, what's point,
Wait, you can't see.
sorry. Okay, what's point I?
0, oh, negative. Is that a 6 or an 8?
Wait, G was not -5, -5. It was
Yeah.
negative.
G?
G is, yeah, -8.
What is this?
That must
Wait.
look like a 5.
That's why we're labeling them.
What is this graph?
That's definitely a negative.
Because if we actually count back, 1, 2, 3, 4, 5, 6, 7, 8. That's an 8.
Lord.
Okay. So I is hitting at, if I count back, -6 and 0.
-6.
And then what's H hitting?
0,
0, -5. Okay? So in your project, I'm going to give you the points, and part of it will be that you're actually graphing it. But that part's nice and easy. And so our first step, it wants us to find the centroid, which is the intersection of the medians. So everything we're doing in this unit has to be really exact. So we're going to find the midpoints using midpoint formula. What's our midpoint formula?
Y1 minus something like that.
Y1 minus Y2
Squared.
squared.
Okay, that's distance. We will use that at some point, but it's just add the x's, divide by 2, add the y's, divide by 2. Okay, I think I need to zoom out just a tiny bit. Okay, so that's what we're doing for the first step is find midpoints. So if I'm doing g to I just plug in my g points for x, so -8 plus -6, divide by 2, which comes out to -7. And then I do -5 plus 0 divide by 2, which comes out to, yeah, so -5 over 2 or -2.5. You can do fractions or decimals, it doesn't matter. Okay, and then to find I to h, so it's -6 plus 0 divided by 2, which gives us -3. And then 0 plus -5 divided by 2, which gives us -2.5. And then our last one is g to h, so -8, which is -4. I did something there. -5 plus -5, which gives me -5. Okay, now that I have those points, what do you think I'm going to do with them?
Put them in.
All lines.
I'm going to graph them, right? So, and it is kind of hard on this because these graphs just printed really weird, but we're still going to get as exact as we can. So -7 I can find easily and come down 1, 2, and a half, which lands me right on the line. Okay, and then I'm going to do my marks here. In your project, it'll tell you to label that another letter, so you'll label the actual point. And then IH, I come -3, come down -5, so I hit that number. That does not look right. -2.5, thank you. -3, -1, 2.5, and again, hit there. And then -4 to -5. Okay, and then we're going to draw straight lines in between. So you use actual rulers on your project if you want to use like the edge of your IE now, or just kind of freehand it. So remember, they go from the median to the opposite vertex. Okay, so then this is called the centroid. We're at the point where they all cross is called the centroid. Okay, and then there's a step 3 here, which we didn't leave space for on the notes, but step 3 is find the equation of the lines that go through the centroid. Okay, so do you guys remember how to find the equation of a line? A little bit? So, equation of lines, we have to find the slope and we have to find the y-intercept, right? And so we're going to do like one line out of each of these things today. We're not going to do every one because then that would take your project time. But I'm going to do the one where I had whole number points. So if I go from I to the midpoint of GH, so I would be the -6, 0, and then midpoint GH was my -4 and -5. Okay, do you guys understand where I'm taking these lines from, the points from?
Is that empty same for like point?
Yeah, midpoint. I probably should label it something else. We should label it like G or something. Or no, JKL. Should we label our midpoints JKL?
No.
Or would that be confusing?
No.
Very confusing. Okay, but what I have to do to find the equation of the line is I take my original point, and then, so I'm taking 2 points from the line. And from those, I find slope. So do you guys remember how to find slope?
Why?
I subtract the x's, subtract the y's, right? So,
Y1, Y2 minus Y1.
so it becomes 0 minus -5 over -6 minus -4. So it becomes 5 over -2, or if you put your other points first, it becomes -5 over 2. So my slope is -5 halves, right? Or I could convert it into -2.5. Either way is fine. And then I plug it into y equals mx plus b, or my point slope form. I think this class told me most of you prefer y equals mx plus b, right? Okay, so then I plug it into my y equals mx plus b. Using either point, I'm going to use point I because it has a 0 in it, and that's nice. So 0 equals -5 over 2 times -6 plus b, and then I solve for b. So what's 5 over 2 times -6? $15, right? And so then I have 0 equals 15 plus b. What does b equal? So then I minus 15. So b, -15 equals b. I know there's not much space for it here. And so then I write my answer, my equation is y equals -5 over 2 x minus 15. You'll do it for each line on your project. This is why we give you 3 days for it. There's just a lot of steps to it. And I have to tell you, most people who, I feel like the most points were lost on this step on the project. So really be careful with this, that you're actually doing the work and getting to the correct equations if you want to get 100 on your project. A lot of people last year just didn't do all that work. I'll give you the rubric. I don't remember right now, but I mean it's a significant amount if you leave all 9 equations
Did you
off.
get a lot of hundreds last year?
Yeah. And a lot of really good grades. I mean, because it's a project, you guys can check each other's work and stuff. So then you can still use your notes and check your work. It's not like it's a really difficult work. There's just a lot of steps to it. Okay. So let's go on to our circumcenter. So we already have our midpoints from the centroid, so I'm just going to copy them down. Okay, same as above. And your project works this way too. You each one kind of builds off the last one.
Oh, so we do centroid, circumcenter, and working center on the project.
Yeah. So you're going to be doing basically just these 3 things. Okay, and then we have to just find the perpendicular slopes now. And so to find perpendicular slopes, we find the regular slopes first. So g to I, if I'm counting up from from -5 and then over 2, if I count up, this would come up 5 over 2, correct? Did I count my slope right? So rise over run. So that's just 5 over 2. And then I to h, so I'm going to come down 5 and then over the 6. And so is I to h a positive or negative slope?
Negative.
So it's -5 over 6. And then how about GH? What do we call that when it's a straight line, horizontal line? 0, yep, our slope's just 0. And then we come over here and find our perpendicular slopes. So perpendicular to GI, remember I just flip it and make it negative, so it becomes negative 2/5. Perpendicular to IH becomes positive 6/5. What's perpendicular to 0? Undefined. Yeah, it is undefined.
Who said that?
You might want to make a star there. That was another place where some people lost points on their project last year, just giving the wrong. I mean, it's not a huge number of points, but still, you want every point you can get. Okay, and then we're going to draw the lines through the midpoint using perpendicular slopes. And so I have to come graph the midpoints again. So GH is -4, -5. And then, because this slope is undefined, I just draw it straight up. That was nice and easy. Now I'm going to come to GI, which was the -7, -2.5. And here I do need to count because this slope isn't exact. So this, I'm going to come down, and this would be a lot easier if our graphs had printed, but come down 1, 2, and over 1, 2, 3, 4, 5. So my next point would be about here. And on your project you have really good graphs, so it will be more exact than what we're doing now. But I'm going to come across, and my line's going to go something like that. Again, it's perpendicular. Then I find my midpoint of IH, which is -3, -2.5. And I count out my slope, so if I'm coming -3 down 6, that's going to be fun. So, okay, so if I can't do 6, I can do two things. I can count half the slope, so I could count 3 over 2.5, or I can just continue the graph as if it was there. Which one do you think is easier to do? Just continue the graph, since we can't even see the points anyway, we just estimate. So again, I'm starting at 2.5, so I'm going to be counting the halves. So 1, 2, 3, 4, 5, 6 would be way down here. It might be easier to come down 3. What do you guys think? Or if I totally lost you?
Yeah, I've been lost in the first.
Okay, so let's review a minute. Are you guys with me on finding the midpoints?
Yes.
You're with me on graphing the midpoints?
Yes.
Are you with me on finding the slopes?
No.
So slopes are just rise over run?
Oh, yeah.
And we just count it out?
It's the third.
Okay. Are you with me on finding perpendicular slopes?
Yes.
Okay. So where did I lose you? Was it the graphing I lost you? Yes?
Got it.
Okay, so all I'm doing here is I'm graphing my midpoints, and then I'm counting out those perpendicular slopes, which granted is hard on these graphs because they didn't print right.
So you're
But
basically doing what you did up first from the top.
yeah, I'm just counting out perpendicular slopes from here. Okay, so because this graph is hard, we're going to estimate, just to save time, but when I graph out the slope, I'd count it and it'd come way down here, but it's going to come and match up exactly. And so when you're doing this on your project with graphs that work and rulers and stuff, your lines should cross exactly in the middle, and that's the circumcenter. Okay? And so then we're going to we're going to go ahead and find the equation of just one of these lines. We're going to do the undefined line. How do I write the equation of undefined? There's still an equation. So is it going to be an x equals or y equals?
X equals.
Yeah, so here it would be x equals what? So just remember, for my undefined slope, still write that equation. So x equals -4. I think your project also will have you calculate the exact point in the center, so you have to then, once you have those equations, systems of equations to solve. But we'll be going over project guidelines in a few minutes. All right, you guys ready for the last one? I know you guys only have 5 minutes, but we'll see how much you can do. Okay, so the good thing here is the first step is to find slopes. We already found those, so we just copy them down. 5 over 2, negative 5, 6, and 0. Second step is find perpendicular slopes. We already found those. We get to just copy them down. Okay, and so here, orthocenter is just the intersection altitudes. We don't have to use midpoint or anything. We just have to count out those perpendicular slopes. And so if I'm finding here, so I'm going to start on I, and my perpendicular slope to I is just undefined. So I'm just going to come straight down here. That's my line. Perpendicular to G, I'm going to start at G and count out my perpendicular. Oh, I do need to point this out. So when I said the perpendicular slope, I have to come to my opposite side, which is GH. So the slope you take is the one that's opposite to your point. So which slope am I looking at if I'm coming from G to hit that line? Yeah, IH. I need perpendicular to here, right? So IH, I count up 6, which is going to put me just 1 above here, and then over 5, which would put me at my negative 3. And then I would use my ruler, because that's a long line. And draw my perpendicular line. I'm going to stop inside the triangle, but I can see that's where it takes me to get a perpendicular line that hits point G. It's going to be on that edge. Yeah, the graphs are not amazing. Okay, if I want to start at point H, which slope am I looking at? GI, right?
Yeah.
So negative 2/5. So I'm going to come from here and go up 2 and back 5. And so I come to my negative 5. My point will be there. And again, I'm going to use the ruler. And I'm always double checking myself, and you guys will be doing this project in pencil so you can erase and fix. Make sure what you draw is logical. Are they all crossing one point? Do they all look perpendicular? Okay. So then that's my orthocenter. And so then to find the equation of one of these lines, I again just take one of the points. So like I would find the point H. So if I do y equals mx plus b, and I plug in my point H, which was 0, negative 5. And so I plug in 0 equals, do I already know my slope of this line? Yeah, which one is it? Yeah, it was 6 over 5. So equals 6 over 5. No, it wasn't 6 over 5. What was the slope? So perpendicular, H means perpendicular to GI. So of negative 2 over 5. I totally did that wrong, sorry. Negative 5 equals negative 2 over 5 times 0 plus b. When I multiply that out, what does b equal? So negative 2/5, it just cancels out when I have 0. And so my equation of that line is just y equals negative 2/5 x minus 5. All right, so what you're doing here is you're using your coordinates to go through the triangle and then find the coordinates of the orthocenter, circumcenter, and centroid, okay? And so we didn't go that far in notes, so you're going a step farther than we did in notes, which will involve systems of equations to use the lines that you found to find that exact center. Okay? And then you'll graph the Euler's line for your triangle. This reviews lots of geometry and algebra stuff. That's why we're doing it. And so just step by step going through, make sure you're going through every step here, okay? So for every single, so this is for the centroid, so you'll turn in one graph with your triangle graphed, and then make sure you've done all of these steps and filled everything in, okay? Was there a question? Okay. I'll come over and answer questions also later if you're a little mixed up later.
Are we putting like the triangle with these points on everything?
Yeah.
So should we just start with that?
Let me finish explaining and then yes, you'll start with that. Okay, thank you. Okay, so then you'll do the same thing for the circumcenter. That's why every group should have 3 graphs. So same thing with circumcenter, where you go step by step through it. And just make sure you're following every step we did in notes. If you estimate things, you're not going to get a good grade on the project. So go step by step, doing everything algebraically. Mm-hmm. And then they'll do orthocenter. And then your reflection is a nice, easy way to get some more points. Just make sure you do it. You just write a few sentences saying, hey, at the end of the project, how was it? Was it really hard? Was it easy? Did you think you learned a lot? And so what you turn in is really important here. So 3 accurately and neatly drawn graphs with everything labeled. Your answer sheet with all the equations, the lines, systems work filled in, and Euler's line graphed, and all the backup work and calculations, and then reflection questions. It says on a separate sheet of paper. I don't care if you do it on one of your sheets of paper. You just need to make sure it's really clearly labeled where it is. Okay, so you'll turn in 3 of, and they'll all be stapled together. So I would write your name on every single piece of paper in case something ever gets left behind. So you'll turn in 3 graphs and this answer sheet. And I thought the grading rubric was on here. I'll have to find that for you. But you'll find your, so this is where you'll like do the work. This follows along like we did with notes. This is where you'll show all your work. And then this is where you will put your final answers. So like the exact equations you found, the systems of equations to find the exact point. Okay? And then you'll graph your Euler's line here. Okay. Any other questions before we split into groups and I can come around and answer individual ones? Yeah. You think it's a question everyone has? All right, what's your question?
On the paper it says like line CD, but it's only like
Oh, that's okay. So it's to help make it clear, when you go step by step through, which one is that? The centroid?
Yeah.
And so it wants you to label the midpoint of AB is D. Midpoint of BC is E, so that you can real clearly find the points of these lines. So each midpoint that you graph, you will label. Midpoint of AC is F. So that's how you'll get the lines like AD or whatever it asks you to do. So as you graph each midpoint, you will label it with the letter it says to label it with. So just make sure you're following step by step through here. Okay, so I'm going to go ahead and stop our recording.